Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Construct smallest number from DI string, Leetcode 2375. If you are new to the channel, consider subscribing. I try to make daily videos on the problems related to data structures and algorithm, including detailed explanations, optimized solutions, and step-by-step walkthroughs to help you improve your coding skills. Now to the problem. In this problem, we are given a zero index string pattern of length n consisting of characters I and d, I for increasing and d for decreasing. And we have to create a zero index answer number of length n plus 1 using the following conditions. Number should consist of digits 1 to 9, where each digit is used at most once. And since there are only 9 unique digits available, the maximum length of the pattern is constrained to 8, as the resulting string number would need to have length of n plus 1, which would be equal to 9 in this case, containing all the digits from 1 to 9. And if the ith character in pattern is I, then the digit in the output at the ith index should be less than the digit at I plus 1th index. And if the ith character in the pattern is d, then the digit in the output at ith index should be greater than digit at I plus 1th index. And we should return the lexicographically smallest string number that meets the condition. A number or a string A is lexicographically smaller than another string B if at the first position where the two numbers differ, the leftmost digit of the smaller number is smaller. For example, if we take the sequence like 1, 2, 3, 5, 4 and another number like 1, 3, 2, 5, 4, then the sequence 1, 2, 3, 5, 4 is smaller because the first index from the left where they differ, 2 is less than 3. Then in example 1, for the given pattern of length 8, our output number string of length 9 is 1, 2, 3, 5, 4, 9, 8, 7, 6. And if you notice, first 3 digits in the pattern are in the increasing order. So our numbers 1 to 2, 2 to 3 and 3 to 5 are in the increasing order. And then we see D. So we decrement the digits from 5 to 4. And then we see I. So we increment the digits from 4 to 9. And then we have a consecutive 3 decreasing Ds. So we decrement the numbers from 9 to 8, 8 to 7 and then 7 to 6. Now there may be multiple valid strings that meet these conditions, but we should return the lexicographically smallest one. And here this is the smallest possible number that meets the condition, so it will be our answer. Similarly in example 2, for the given string DDD, the lexicographically smallest possible number will be 4, 3, 2, 1, where the numbers are in the decreasing order. Now in terms of solution, the most naive strategy would be to generate all possible strings of length n plus 1 consisting of digits 1 to 9 and then verify which of them satisfies the condition defined by the pattern. And then from all valid strings, we will return the lexicographically smallest one. However, this approach is computationally expensive because for each digit we have 9 possible choices. And given the length of the string is n plus 1, there will be 9 to the power of n plus 1 possible combinations, resulting in overall time complexity of O of 9 to the power of n, which is exponential. To optimize this, we can use a visited set to keep track of digits that are already used in the current string which is being constructed. And in this problem, it is specified that each digit can be used at most once. So then instead of 9 to the power of n plus 1 possibilities, we focus only on permutations of digits 1 to 9 of length n plus 1. For first position, we have 9 choices, that is digits 1 to 9. And once a digit is used, for the second position, we only have 8 valid choices. And then at the third position, we will have 7 valid choices and so on. And now this can be done in n plus 1 factorial ways, resulting in factorial time complexity. And when comparing the factorial growth and the exponential growth, factorial growth is generally faster and worse in terms of time complexity, especially as n becomes larger. However, in this problem, given the constraint that n is less than equal to 8, factorial time complexity will be less than exponential time complexity. And given the constraint, this solution will be accepted as well. And in case you are interested, I have covered this solution in the post linked in the description below. Now let's try to solve it in an optimal way. Let's take some examples that will help us derive it. We aim to build the lexicographically smallest possible number string. To achieve this, we should process the string from left to right as the numbers are constructed incrementally, because we want the smaller digits at the most significant position and larger numbers at the least significant positions. This maintains the smallest lexicographical order. For example, if we have 3 digits 1, 2 and 3 available, then 123 will be the smallest number that can be formed from those digits, because the smallest number 1 is at the most significant position. This is the most significant digit. Then the second largest number 2 is at the second most significant position, and the largest number 3 is on the least significant position. Now let's try to find the answer for the string with these 3 i's. Now when we see first I, it implies the next number would be larger than the previous one. So we pick the smallest number first, that is 1, and then the next smallest number, that is 2, and then we see I again. So we increment from 2 to 3, and when we see I again, we increment it from 3 to 4, and that's why our result will be 1, 2, 3, 4. Now let's take another example with 3 D's. And now when we encounter the first D, it means the current number should be greater than the next one. So we pick up the second smallest digit, which will be 2, followed by smallest digit 1, resulting in 21. But then we see D again. So when we see the second D, at that time, this sequence is not valid. And instead, we should be now picking up third smallest digit, that is 3, followed by second smallest digit, that is 2, followed by smallest digit, that is 1. And now when we see the third D, this will be reset as well, and we will be setting 4, 3, 2, 1. So here we got the answer as 4, 3, 2, 1, which is in decreasing order. Let's take one more example. Let's take the string as IID. So here when we see the first I, we want the increasing order. So we pick up the smallest number and the second smallest number. Then we see the next I, so we increment the number to 3, and then we encounter D. And if we decrement from here, we will again get the number 2, which is not allowed. So that means this 3 is no longer valid. But what is the next larger number that we can pick? That is 4. Because if we pick up 4, then this D can be assigned 3, which results in a decreasing sequence, and each of the digits is used at most once. So did you notice something? Whenever a D is arising, the sequence is reversing. So instead of 1, 2, 3, 4, like we saw last time, now it became 1, 2, 4, 3. But let's build on it further. Now let's take the string double I and 3D. So again for first I, we can assign the sequence 1 to 2. Then we see I again. So we assign the value 3 here. And then we see D, which means the sequence should decrease. And again we cannot take the value 3. So we look into the future and see how many consecutive D's are there. And here there are 3. So instead of value 3 here, the value should be 6, so that it can decrease 3 times, and we can get this value 3 here. So we got the value 6 here. Then we saw the value D. So we decrement the sequence. Then we see D again. So we decrement the sequence. And then we see the D again. So we get the value 3. And now our sequence becomes 1, 2, 6, 5, 4, 3. So what this means is whenever we see the D's, the sequence gets reversed. And now let's take a bigger example just to quickly see it. So when we see 2 D's, then the sequence reduces from 3 to 2, then 2 to 1. And then we see I, so we increment the sequence. Then we see 2 D's, so we should reverse the sequence. So we will get 6, 5, 4. And then we see the 2 increasing I's, so we will get 7 and 8. But then we see the D again. So we reverse the sequence and get 9, 8. So our output will be 3, 2, 1, 6, 5, 4, 7, 9, 8. So whenever we see an I, we can quickly perform the action and increment the digits in the sequence. But whenever we see the D, we have to look for the consecutive D's in the future, and based on that we group these digits and reverse their order to satisfy the decreasing condition before appending them to the sequence. And which data structure can help us reverse these sections or groups? The answer you would have guessed it by now, the stack, because of its last in first out behavior. So then our approach can be that we iterate on the string from left to right while maintaining a stack. And for each character in the input string, we push the digit onto the stack, starting with smallest value, that is 1, and increment the sequence. Now we can either see the character I or D. Whenever we see D, we do nothing immediately because we want the part of the sequence in the decreasing order, and that we can know only when we count all the Ds that will come together in the future. So to achieve this kind of a delayed processing, we keep pushing the digits onto the stack. So we start with the digit I equal to 1 and first character in the sequence is D. So we push 1 onto the stack but don't pop it yet. Then we see the D again and the digit is equal to 2. So now we push 2 onto the stack. Then the next character we see is I and digit is equal to 3. So whenever we see I, we pop out all the characters from the stack, which will reverse the sequence of the group. So we pop out 3, 2, 1 and append them to the answer sequence. So now our answer sequence becomes 3, 2, 1, which matches this sequence so far. Now our digit becomes 4 and we see D in the sequence. So we do nothing but just push 4 onto the stack. Then we see D again and digit is equal to 5. So we push digit 5 onto the stack. Then we see I and the digit is equal to 6. So we push 6 onto the stack and pop out all the characters to reverse them. So we pop out 6, 5, 4 and append them to the result string. Then the next character we see is I again and digit is equal to 7. Let me draw a new stack because I don't have any space remaining here and push 7 onto the stack and pop it out as well from the stack and append it to the answer string. And then we get D and the digit will become 8. So we push 8 onto the stack and increment the I to 9. And since the pattern length is equal to 8, our answer sequence should have length 9. So this is the last digit we have to process. So we add 9 to the stack and now we are done with all the digits and our stack is not empty. So we pop out the elements from the stack and append them to the answer string. And in the end, our answer will be equal to 321654798. And one last point, since we are building the answer string from the scratch, we would need to use mutable string implementation in programming languages like Java and Python, like string builder in Java or list in Python. Now let's jump into the code part. First, let's get the length of the input pattern n. Now let's create the answer using the mutable string implementation like string builder in Java to construct the resulting string. Let's initialize the stack to store the digits temporarily as we process the pattern. Now we will run the loop from 0 to n being inclusive here because our answer will have n plus 1 digits. Now we push the current number I plus 1 onto the stack. Now we check if we have reached the end of the pattern, that is I is equal to n, or we have encountered the character I. Then we will process the stack if it is not empty by popping out all the elements from the stack and appending them to the answer string, which results in reversal of the group. And once we are done with all the digits, we will convert this string builder back to string and return the answer. Now let's submit this code. Cool. Now in terms of time complexity, it will be O of n, where n is the length of the pattern because each digit is pushed and popped from the stack exactly once. And in terms of space complexity, it is O of n for using the stack and storing the result. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.